Okay, in this video we're going to talk about simplifying radical expressions. So a radical expression is any expression which contains a square root like these. And before we start with something big like this, we should start with a simple radical, like take the square root of 50 for example. 50 is not something that we would call a perfect square because there's no number that when you multiply it by itself you make 50. So when you have a number that's not a perfect square, you can get the prime factorization of the number and see if there are any squares in it. So if I take the number 50, the smallest prime number I can divide into 50 is 2. So I divide 50 by 2 and I get 25. 25 is divisible by 5 and 5. So 2 times 5 times 5 is how we write the prime factorization of 50. So what I do is I replace the square root of 50 with the square root of 2 times 5 times 5. And now that I see that there's a pair of 5s in here, that means there's a perfect square inside of 50. So I can take it out because the square root of 5 times 5, square root of 5 times 5 is just the square root of 25, which is 5. So I can actually take this out of the radical and put a 5 out in front of the radical. So it's 5 times 5 multiplied by the square root of 2. So this is the simplified expression of the square root of 50. So I need to do this for each of the ones in this expression. So let's start with 18. The square root of 18 needs to be written as prime factors. So when I prime factorize 18, I get 2, divide by 2 you get 9, divide by 3 you get 3. So 2 times 3 times 3. So again we see a pair here, and that means there's a perfect square. So I can take out a 3 out in front, and it would be 3 times the square root of 2. So the square root of 18 is the same as 3 times the square root of 2. So I'm going to rewrite that over here in this expression. 4 times the square root of 2. But remember we took a 3 out, so I'm going to take out the 3 and put that with the 4 that's in front. So now I actually have 3 times 4 times the square root of 2. And I'm going to continue doing this for all of my numbers here that have factors, that have squares as factors. So 75 can actually be written, we'll do this on some scratch paper. 75, the square root of 75 is the same thing as 3 times 5 times 5. That's the prime factorization. So you see I can take out a pair of 5s and it would be 5 times the square root of 3. So the square root of 75 can be rewritten as 5 times the square root of 3. 5 times the square root of 2. 2 doesn't have any ways to break it down, so we have to just leave it. 5 times radical 2. And then minus 3 times the square root of 27. So another one would be 27. If we do the prime factorization of that, we would get 3 times 3 times 3. And since there's one pair of 3s, we could take the 3 out in front and have 3 times the square root of 3. So bringing that back to our problem over here, I have 3 times the square root of 3. Remember, because I took one out and I put it in front. So now we can actually start to simplify and add like terms. So first I'm going to multiply the coefficients here and here. So I actually have 12 times radical 2 minus 5 times radical 3 plus 5 times radical 2 minus 9 times radical 3. So just like when we're adding like terms with x's and y's, we can add the ones that have the same radical. And when we add them, we just add the coefficients. And so this term and this term have the same radical, so I can add 12 plus 5 to get 17 times the square root of 2. And I can also do the same thing with the other ones, with the ones that have the radical 3. So negative 5 and negative 9, which gives me negative 14 times radical 3. So you're only adding the coefficients. So we should try another example. Similar example. If I have -5 times the square root of 3 minus 3 times the square root of 300 minus 5 times the square root of 27. So again, I'm going to use prime factorization to break each thing down. I can't break 3 down, but I can break 300 down. And actually there's kind of a trick with bigger numbers like this. If it ends in zeros, we know that 300 is the same thing as 3 times 100. And we could break the 100 down further, but since we already know what the square root of 100 is, we can just take it out because we know the square root of 100 is 10. So it would be 10 times the square root of 3. So I have 5 rad 3 minus 3 times 10 times the square root of 3. And then 27, which we just did earlier, was 3 times 3 times 3. So remember we took out 3, and we had 3 radical 3. Minus 5 times 3 radical 3. Again, I do the same thing here. I look for like terms. Actually, these are all like terms because they all have radical 3. So I can go ahead and add the coefficients. Before I do that, I should multiply these things though. So I have -5 rad 3 minus 30 rad 3 minus 15 rad 3. So -5 minus 30 is -35. And then -35 minus 15. Doing it on a calculator because I'm lazy. -50 times the square root of 3. And so that's how we simplify radical expressions.